Hey, everybody. Welcome to Microsoft Learn Live. So I am Colin Cole, and I am an engineering lead with our Azure Fast Track team in Americas that focuses on our app dev cloud space in Azure. So we cover things like Azure Kubernetes services, app services, API management, and just kind of a bunch of the other PaaS services that you use for application development. Joining me today is Sonalika Roy, who I've had the pleasure of working with for quite some time. She's actually on my team, and I'll let her say hi.
Hello, everyone. I'm Sonalika Roy, and I'm a senior engineer here at Microsoft, and I'm in the same team as Colin. Over to you guys.
Awesome. Thanks, Sonalika. So what we're going to do today is cover into AKS, Azure Kubernetes Services Security Best Practices. But before I jump into kind of going over our agenda, I also want to point out our colleague from our team, Jamal Brown, who's one of our engineers as well, who is working the moderation today. So he'll be answering questions out there. Thank you very much, Jamal. So what we're going to be basically covering today is one of our most important services we have, probably the most important that we have in our team, which is Azure Kubernetes Services. And we're going to be covering security best practices. So, but real quick, Sonalika and I, and actually Jamal as well, we all work in Azure engineering in a group called Fast Track for Azure. So we're part of Azure engineering, and kind of what we do is we help customers properly deploy Azure workloads, kind of following cloud adoption framework and well architected framework best practices. So what we're going to do for you all today is kind of show you what we do with customers when we're talking about this. So the kind of stuff we're going to talk about here is exactly what we do when we're working with customers to help them properly deploy their AKS workloads. There's many aspects to securing an AKS cluster, right? This is an involved piece of technology. There's lots of content here. We're going to cover most of the things that you'll want to know. Not everything, because there's just no possible way you can cover every aspect of security. We're going to cover the things that you should probably really think about first. This won't be demo heavy. But we're not going to drill in excruciating detail into each topic. Intention here is to kind of go over all the salient, most important points that you're going to care about as you're securing your cluster, and we're going to leave you behind with pretty much a collection of links to everything we're going to talk about, so you can kind of go in and drill into all of these topics as you're working. You can sort of see here the level of things that we're going to be covering today, starting off at the cluster level, going into networking concerns, developer and configuration concerns, and even image management. What we're not going to cover is application security identity best practices, right? So the application identity itself, we're not going to touch that. We're really focused on the Kubernetes part of this and the Azure parts. Okay, and so feel free to ask questions for the moderator, for Jamal, and we'll just go ahead and jump in. So I'm going to go ahead and close down my PowerPoint here. And really the first thing I want to do is just mention that, of course, so AKS is a managed service, right? Azure Kubernetes Service. It's a managed service. We manage the control plane, the API server for you, for the customer. There's agent nodes that also live, that run your application, right? They run your workloads. Those are going to basically get put into your secure virtual network in Azure, and they're going to be exposed with private IP addresses, private endpoints. So there's really nothing you need to do with those, right? They're already privately exposed. However, that API server is by default publicly exposed. So if you don't do anything, you're going to get a publicly facing endpoint that points to the API server nodes, the control plane that we manage for you. That might not be what you want. So one of the initial best practices that we want to quickly point out here first is to use a private cluster. And to do that, you're going to basically, when you create your cluster, you're going to enable, apologies, little screen mess up there, but you're going to basically select enable a private cluster when you go ahead and create that cluster. And what that's going to basically do is that's going to create, it's going to use something called private link, and it's going to connect the API server to those agent nodes that are running in your virtual network over a private endpoint. And there will be no public endpoint exposed for the API server, the control plane. The impact of this is that you're going to need to have a Bastion server connected, a jump box, if you will, connected inside of your virtual network, probably in the hub of the virtual network, that allows you to manage that cluster, because you won't be able to connect to it from outside of the cluster, outside of the virtual network, because there's no public endpoint. Additionally, with CI/CD, with DevOps, you're going to need to have agent nodes running inside the virtual network when you're doing deployments, because you have no exposed public endpoint. And many of the best practices that we're going to talk about today are actually included in what we call this baseline architecture for Azure Kubernetes Service. This is a great way to go ahead and get started. This is a reference implementation. A lot of work's gone into this. This is out in GitHub, and you can kind of go out here and you could start off with by creating a cluster using all of this sort of contained best practice with this reference implementation. It's all documented, and you're going to get a bunch of the best practices included that Sonalika and I are going to be talking about today. If you do choose to go with a publicly facing cluster, though, you're going to want to, so sometimes you do want a publicly facing cluster. There are scenarios where that makes sense. But if you do that, you absolutely want to lock down that public IP so that it can only be accessed by an authorized IP range. And the way you do that is when you're creating a cluster, you simply pass in an API server authorized IP range to the cluster. You can also update an existing cluster with this as well. So you can use an AKS create update, and you can pass in that same authorized IP range. And Sonalika, do you want to mention something that we have in the pipe on this?
Yeah, actually, like, you know what, like before we were using private link to connect to API server in the control plane. But now there is a feature in preview where you can integrate those API servers within your own VNet. So instead of using private link, you will be able to inject your API server in your own subnet. So all the traffic will flow within your VNet itself. So that is something coming up, and it will be cool.
Excellent, excellent. I'll switch you over to you, Sonalika.
Okay. So yeah, when it comes to Kubernetes, right, there are like different ways to authenticate and authorize to Kubernetes clusters, like Kubernetes role-based access control, where you can grant access to only the resources you need, right? But for AKS, you can also further enhance security by integrating Kubernetes RBAC with Azure Active Directory and Azure RBAC. So Azure AD authentication is provided to AKS clusters using OpenID Connect. It is best to use Azure RBAC for Kubernetes authorization for unified management and access control across Azure, because you will be using Azure Identities and RBAC to authenticate to all other services. So if you use Azure RBAC for Kubernetes authorization, you will get unified management experience as well. You can enable AD, but if you see my screen here, you can enable AD by having this feature enabled when you are creating the cluster, or you can also update it once the cluster is created. Also, one thing I want to mention here is, like, when you create a cluster, right, and you integrate it with AD, by default, local accounts are enabled. This allows someone using kubectl to use admin access, and they will get full access to your cluster, and this cannot even be audited. So it is best to disable local Kubernetes accounts when integrating it with AAD, and do all RBAC level permissions through AAD accounts, which are like auditable and cloud integrated as well. So there is no backdoor to your cluster where people are um, uh, using admin access to your cluster, right? So with AAD integration, local accounts are not needed. Uh, and to do that, to disable it, if you see on my screen, you can, like when you are creating the cluster, you can add this feature in here, disable local accounts. It will disable all the admin access for your cluster. And in any case, I don't know, like Colin, have you seen customers actually need to enable local account on their clusters?
It's a good question, Sonelka. I haven't seen the need, right? I mean,
Yeah.
the thing is though, is that when you use that //admin at the end, it makes it so easy to do things,
Yeah.
because you now have full power over that cluster locally, and which is very dangerous and gets around everything in terms of all the role-based access that you want to potentially limit to someone's AAD account. So definitely don't do that. Don't allow the --admin. Absolutely disable local accounts.
Yeah, I totally agree. And in case, like, if you need to enable local account for some scenario, make sure you limit access to your cluster configuration file by assigning the appropriate roles. So Azure provides you built-in RBAC roles like Kubernetes Service Cluster Admin role or Azure Kubernetes Service Cluster User role, and you can select appropriate role as needed or create a custom role as well, right? And one more thing I want to mention here, like when you create a cluster, you assign a user to the cluster to perform operations on the nodes using RBAC, right? So when when you create this cluster, make sure you use user managed identity instead of system managed identity, because if in case you have to like recreate your cluster, your identity is still available, and as you know, like system assigned identity is tied to your resource life cycle. So it's better to use user assigned identity in all cases, so that you can always recreate your cluster using the same identity, and you don't have to like reassign all the permissions which is needed. So yeah, Colin, over to you.
Yeah, that's a great point, Sonalka. Thanks for reminding everybody of that. User assigned identities when possible, for sure. So I'll go ahead and switch over to my machine now. And related to what Sonalka just talked about is, because we're now integrating our clusters with Azure Active Directory, we get a whole bunch of additional features. Probably one of the most important ones, and this is something you had to do, a couple of years ago when you started off with Kubernetes and in our initial AKS implementations, because we didn't have this feature of integrating with AAD. You would basically have to authenticate your cluster to your container registry, in this case, the Azure Container Registry, with Docker login password, basically called the admin user in Azure Container Registry. So you would basically be storing this Docker username and password inside of Kubernetes, and it would use that to authenticate to your container registry so it could pull images, right, for containers. Really, really bad idea. You don't want to have any passwords stored anywhere. And so because we have Azure Active Directory integration, we can now use RBAC and use a role to allow the managed identities that exist in the agent nodes to connect to the cluster securely. And it's really simple to do that. All you have to do is simply, when you're creating the cluster, go ahead and use this feature, attach ACR. That will automatically set up the managed identity, and it'll give the managed identity ACR pull role access to the to the registry. And if you forgot to do it, well, you can always do it later by simply using an AKS create update call, and then pass in that your Azure Container Registry. So so that's totally builds on what you're talking about, Sonalica, with integrating with Azure Active Directory, something you just have to do to get the most secure implementation. Additionally, we want to point out that monitoring isn't necessarily sort of a security thing, right? Well, I mean, we're not by enabling monitoring on your cluster, you're not going to become, there's not like a security feature that's going to get turned on. But monitoring is really important, and I guess I like to cook a little bit. I like to cook, Texas style barbecue. It's one of the things I like doing, and so you're smoking meat. And one of the sayings we have in barbecue is, "If you're looking, you ain't cooking." So basically, like if you lift the lid, you're essentially shutting everything down that you just started, and you no longer raising that meat up to the right temperature. So the exact opposite of that is true here. You want to look. You want to be able to see what's going on with the cluster really at all times. So because of that, monitoring is absolutely something that you should understand, and you should include into your secure implementation of your AKS cluster. And we have something called Container Insights. This is a feature that's designed to monitor the performance and all of your container workloads, and we'll also create alerts that you can get alerted on all sorts of things. I'll show you that in just a second. This technology is really cool because it applies to Azure Kubernetes services, but it also applies to Azure Container Instances, Azure Container Apps, ACA, as well as ARO, so our Red Hat OpenShift managed service that we have in Azure. In addition, you can also use this for managed clusters that are running in Azure Stack or AKS Engine. So we have it for self-managed as well as managed container offerings. And in addition, this also works with our Arc-enabled Kubernetes clusters that you might be running on-prem. And of course, Windows and Linux covered here. So this is an incredibly cool set of services for just kind of inspecting what is going on, which you really need for a service to be secure. So just to kind of show you a little bit about this. And by the way, we have things like Prometheus integration with this without having to stand up a Prometheus server. So if you're interested in those kind of metrics, the Prometheus metrics, you can absolutely set that up. But just to kind of quick show you, I will launch into the Azure portal here, and I have a service that I put together last night, just a quick small service running in a cluster that I deployed. And here's my cluster. And note here, if I, this is a little bit large, so let me just go ahead and shrink it down a tad. Okay, there we go. So this cluster off on the left, we have what's called Insights, Container Insights. You'll see that. And so you'll just click here. Now, when I created the cluster, I integrated this cluster in with Azure Monitoring. And what you get, and we're not going to cover everything here, but just show you a few features. What you get here is some incredible out-of-the-box visualizations that cover the cluster, cover the nodes, controllers, and individual containers. So if I click on containers, I can find here a container that I deployed as a test container just to kind of demonstrate some of the power of our Azure monitoring. It's called this web app log test container. If I select this here, I will be able to see a bunch of information about this container that's useful for me to know. This container was developed in C#. So if I launch into that, I can just quick show you here really briefly that what we're doing in this container, and let me just make this a little bit smooth, is we're just kind of running what's called console write line statements, which writes things out to the standard out stream in Linux. This is something that you can do in pretty much any language. It's a way that you typically want to monitor containers, right? You're constantly sending logs out there. And if you write anything out to standard out, that is going to get automatically picked up by our logging service. And you'll be able to see live logs showing those messages from a troubleshooting perspective, which is really handy. So if I go here this is the application running, and I switch over to the privacy screen or click on the home screen, you'll be able to see off on the right that those logs are being shown here in near real time, right? Maybe a second delay inside of the live log monitoring. So that's a really great feature for troubleshooting. Didn't have to do anything to set that up, and you just get it, and it works with just pretty much any language that supports standard out. In addition, we have something called recommended alerts, which I can go ahead and turn on really quickly here, and I can see a whole bunch of interesting alerts that I can easily enable, which will let me know, hey, when a container reaches a certain CPU percentage, I'm going to want to know about it. When a node reaches the CPU percentage, I want to know about it. I'm going to want a text message, or I want an email. However it is you want alerted, you can get that, and that's all kind of sort of simple, out of the box, ready to be used without having to do much setup. So really, really important to log. One last thing to point out, and this is probably the most important from a security perspective, is if you go down to diagnostic settings off here on the right of this cluster, I can select that, and I can go in and actually turn on diagnostic log capture for my control plane. If I'm going to want to open up a ticket, say I do have a security issue with my cluster, or I think there is, and I want to get Microsoft support to help me, they're going to need to be able to look at these logs. And if I didn't turn them on and I'm not capturing this data, then I really can't get it later, right? So it's important for production clusters to turn on some of this logging and capture the most important logs that you can then send to your log analytics workspace if you want to use KQL, Kusto queries to pull out, or maybe a different spot that you want to be able to send them to. So definitely do that. And I know, Sonalika, you've actually seen cases where there are limits here, right? I think that you've seen before. Oh, okay. Looks like we lost Sonalika temporarily. So we'll just keep going, and hopefully she'll figure out what her issue is and get back in. But basically, there are limits here that that you'll have to be concerned about in terms of workspace daily limits and whatnot. Okay, so kind of continuing here, and I'm going to talk a little bit about node security while we wait for Sonalika to jump back in. So from a network security perspective, there are a few important things that you need to know about. Let me just close this window here. And basically, I mentioned earlier that when you're setting up Kubernetes, right, the agent nodes are going to go into a virtual network that you specify. That virtual network is going to have a subnet. The subnet, naturally you're going to say, hey, can I put in some network security group rules around that subnet so I can kind of lock things down around ingress and egress of what's allowed to come into that subnet from a north-south perspective, from a networking north-south perspective, and you absolutely can do that with Azure Kubernetes services. What you can't do, though, what we definitely don't want you to do, is set up any network security group rules at all on the NICs. So don't add any NSGs to the network interface cards of the actual agent nodes. All right, so of the nodes that you're managing in your node pools. That's not supported by AKS. Don't touch those. Do not put an NSG there. You may put NSGs on the subnet for both inbound and outbound. Just note that you want to ensure that you do not block management traffic. More on that is here. We have this link in the collection, so you'll be able to see that. In addition, you can ensure that you're kind of mapping to really the whole network flow. And we'll get into this more of this as we go here. But essentially, what we're talking about with the network security group rules applied to a subnet, that's covering the north-south perspective of the network. The east-west perspective is within the actual Kubernetes service itself, right? And that's something that you can do. You can actually really lock that down with what's called network policy. We'll have Sonali talk about that in just a minute when she gets back on here. But we'll come back to that. So absolutely note the flow. Oh, looks like Sonali is back. Excellent. So Sonali, I just finished talking about network security. I'm going to back up here and let you pick it up on the Azure Defender for containers. So we have a little bit of feedback.
Okay. Can you hear me?
We can hear you fine. Yeah, no worries at all.
Okay. So yeah, so for Azure Defender for Containers, Microsoft Defender for Cloud is a tool for security posture management and threat protection. This tool has many plans, and one of them is for containers, which is called Microsoft Defender for Containers, and it is the cloud-native solution for container security. This plan has merged two previous Microsoft Defender plans, Defender for Kubernetes and Defender for container registries. It protects clusters running on AKS, EKS, like on Amazon, Google. All the Kubernetes clusters are protected, can be protected, or can be secured using Azure Defender for Containers, and these can be enabled through Arc-enabled Kubernetes. So to secure your containers, Defender for Containers collect different logs and analyzes it, like audit logs and security events from the API server. Then it collects all the cluster configuration information from the control plane and workload configuration, and also like security signals and events from the node level. What it does, basically it has two components. First is like Defender security profile. What it does is basically like it deploys a daemon set to each worker node. It collects security related data and sends it to Defender for analysis. This daemon set is required for runtime protection and security capabilities provided by Defender for Containers. And second is like Azure Policy add-on for Kubernetes, which collects cluster and workload configuration. We will go into Azure Policy after Defender, but let's see what Defender can provide to us, right? So Defender for Containers is not enabled by default, but you can enable it through Microsoft Defender for Cloud for a fee. For AKS, it offers both hardening recommendations and control and real runtime threat detection alerts. And for ACR, we have image scanning on the registry, where we leverage Qualys as a base scanner. So let me quickly show you here. 1 second.
Can we see your screen, Sonali, or were you able to get that back?
Can you see my screen?
I think we can switch to it, or maybe you need to share.
I think I have to share it again.
Yep.
So okay, I'll try sharing it here. Okay.
All right.
Okay, sorry about that.
Excellent.
So what I was saying is like Defender container plan is not enabled by default. So to enable it, you can enable it through Microsoft Defender for Cloud for a fee. So you have to go within it and go to environments and Defender plans, and you can select the plans you need. And one of them is containers, right? So you can see like it is not free. It is like $7 per VM core per month. And you have option to enable a provisioning, where it will provision all Defender daemon set, which I was just talking about. And you can also enable auto provisioning of Azure policy for Kubernetes. I'll go in details on Azure policy a little bit later. But for Defender, what it provides us is like a couple of things it does, right? So first is hardening. So what it does is it assesses the configuration of your clusters and compares them with the initiatives applied to your subscription. So you will have some policies or initiatives applied to your subscription for Kubernetes, and it collects all those configuration of your clusters and compare it to them or against them. And when it finds misconfiguration, Defender for Cloud generates security recommendations. For example, like role-based access should be enabled in your clusters. And then that is for hardening. And then it also does vulnerability assessment. So for Defender for Containers, like Defender for Containers scans images for vulnerabilities stored in an ACR. What it does is that it pulls the image from the registry and runs it in an isolated sandbox with the Qualys scanner on it. Image scan is triggered for every image that is pushed, pulled, or imported into the registry. It scans like recently pulled images as well, like weekly. If the Defender security profile is deployed in a cluster, it will initiate a weekly scan of the running images pulled from ACR as well. So whatever is running on your cluster, it will scan those images as well on weekly basis, provided that your daemon set is running on your cluster. And I will show you like some of the recommendations here, which it shows. And so like whatever it will find misconfiguration, or if there is any recommendation on the images, or it is there is any vulnerability found in your images, it will provide those recommendations under this recommendation tab in Microsoft Defender for Cloud. You can add like resource type and all those filtering here, and you will be able to see all the recommendations provided by so if you can see here, running cluster images should have a limited findings resolved, right? So it basically like scans your images, and it will provide if there is any recommendation for your images, it will provide those under this tab, and you have an option to go and fix it. So as I said, like it provides scanning of container images both in a registry and at runtime, and runtime scanning is currently in preview. You can also enable CI/CD vulnerability scans into your GitHub workflows, which is in preview currently. So these are some like cool features. Yeah, Colin.
I was going to say, yeah, sorry to cut you off. Yeah, that's really fascinating. So basically, we got all the way from building the image, right? So from the development flow with the CI/CD pipeline, we can now scan at all the full kind of shift left kind of paradigm. So we can scan the stuff that we're building. Then we can scan within Azure Container Registry when stuff gets pushed in. There's a bunch of different triggers there. And then we can, with this technology, we're actually looking at the overall cluster and all the cluster logs and looking for any sort of kind of security issues that are happening there. And then all the way down to the runtime level too, right? With the nodes and having some node scans happening as well to ensure that applications aren't doing certain things.
Yeah. So we like once it is it is out of preview, like customer will have end-to-end protection if they implement this. So that would be very nice, and especially like CI/CD I really like. So it is very difficult to scan images when it is implemented from CI/CD pipelines, and if this feature goes G8, it would be a very cool feature. Yeah, and then it also provides runtime threat protection for nodes and clusters. Threat protection at the cluster level is provided by Defender profile and analysis of the Kubernetes audit logs. Alerts might be like expose Kubernetes dashboards or creation of high privilege roles. So any these kind of threats are scanned, and it will be provided as an alert for you. It also provides host level threat detection. A daemon set that runs on all of the nodes in the cluster inspects activity on the Kubernetes worker node to detect suspicious activity, and that runs by the containers on the nodes. So when Defender for Container is enabled on a cluster, it will monitor the Kubernetes API operations to find all the suspicious and malicious activities in the Kubernetes control plane. Under the hood, Defender collects the API logs over the Azure backbone, analyzes those, and presents the findings. The process of collecting and analyzing is like kind of transparent, and there is no cost associated with storing the API logs itself. So without without any cost, you will be able to monitor all those API logs as well. And if there is any malicious activities going on, Azure will provide those recommendation or alerts to you. Then we have Azure Policy, which I was mentioning before. So second part of that was Azure Policy add-on, right? So Azure Policies, what is Azure Policy? Azure Policy is a set of governance and compliance rules to enforce organizational standards and to assess like compliance at scale. You can protect your Kubernetes workloads by installing Azure Policy add-on to your cluster, right? So we just saw like there is an option to enable on the subscription level as well, and you can also enable it on the cluster as an add-on. And I can just show you quickly here. So when you have to enable the add-on, you can say like AKS enable add-ons on existing cluster, and also like while you are creating, you can add these like parameters into that, and it will enable Azure Policy add-on on your AKS cluster. So you have option to automate it across all the cluster within the subscription, or you can add it on individual cluster as well. So Azure Policy, so you might have heard of pod security policies, right? Which is actually now replaced by Azure Policy. Azure Policy extends Gatekeeper version 3, which is an admission controller webhook for OPA, like Open Policy Agent, to apply at scale enforcement and safeguards on your clusters in a centralized manner. Azure Policy makes it possible to manage and report on the compliance state of all your Kubernetes clusters from one plane. So everything will be in Azure Policy. All the recommendations or any non-compliance report will be available from Azure Policy for all your clusters which you are monitoring. Then this add-on requires 3 gatekeeper components to run: 1 audit pod and 2 webhook pod replica. So basically these components consume some resources on your cluster. So like when you enable it, keep in mind that some of the resources what you have for your node will be assigned to these, or will be consumed by these pods which will be running on your nodes. So once you have enabled add-on policy on the cluster, you can assign the Kubernetes policies to cluster. And once the policy is assigned, what it does is the add-on downloads the policy assignments and installs the constraint templates and constraints on the cluster. And it maps to your Azure policy definition and policy assignment. So it monitors your cluster, it will gather your compliance, it will audit logs and gather your compliance results. And because it has those mapping details of your policy, it will send those compliance details back to your Azure policy. And that is your like common dashboard from where you can go and monitor all the Kubernetes clusters in there. So I can quickly show you here how it looks like. And while it opens, some of the commonly used policies, what we have seen is like your Kubernetes cluster should be private. And if you're using Kubernetes public clusters, like Colin, I don't know, like, have you seen customers using public clusters? I have
not. I have
yeah.
not. But I think Sonalika, earlier in this, I talked about if you are using a private cluster, you absolutely need to have an authorized IP range, correct?
Yeah.
And you can have that, you can control that or check that with a policy, correct?
Yes, that is correct. So can have a policy which will uh, it's called Kubernetes cluster services should only use allowed external IPs, and you can say, okay, only these external IPs are allowed, and it whenever you will create a cluster and anything else, if you someone tries to add in authorized IPs for your cluster, it will deny it. So with policies you have an option, different options for policies, like what your policy is supposed to do, right? Whether it you just want to audit your clusters, or append if something is missing in your cluster, right? Or you can, like, if you want your environment to be secure from start, deny is a perfect option for you, where no one can go and even like try to deploy unsecured resource for you. So there are like different options like these Kubernetes policies which we have in here. You can, when you assign it on a cluster or to your entire subscription where all clusters will be encountered under that, you have option to whether you want to audit or deny or append or deploy if not exist. Those options are available. Of course, it will depend based on policies what you can do or not. But if you want to secure from start, deny is the policy or effect you want to choose for your policy. And if you want to just audit at the first, like, right, like I'm just starting to use Azure policy, and I just want to see how it works, just assign it in the audit mode and see what non-compliance report it provides to you.
Makes
And
sense.
one more thing I just want to mention here is that um, use pod security context to limit access to processes and services, or privilege escalation, right? So if you're using those pod security contexts within pods, and say like your uh, privilege uh, privilege access is not is set to false or true, and then you have another policy which says you have policy assigned to cluster which says like it should always be um, false. So if you have true in your pod, it will not work. So you have to make sure that whatever you have in the pod security context is does match with your Azure policy.
Got it. Got it. And that's great advice. And you've personally been writing. You've actually been writing a number of custom policies for our product team for some of our services like API management. I know you wrote some recently and stuff like that. So you know this space very well. But absolutely, these policies are critical, like denying root access to pods, pulling images from trusted registries. You know, there's a number of them that you're going to want to absolutely enforce so you have that proper governance.
Yeah.
Okay, so we'll switch back to my machine. And so I mentioned already about NSGs and how to use those for north-south networking traffic coming into the cluster and leaving the cluster. That's what we would call north-south. East-west is sort of the term that's used to define the traffic that's inside of the cluster, kind of the pod-to-pod traffic between applications. So Sonalika will cover that in just a second. But so absolutely, you can use network security group rules, as I mentioned, but just do them in the right place. Do not put them on the NIC, and make sure you don't block management traffic. Additionally, we want to talk a little bit about private link. So we mentioned earlier that you don't want to, most of the customers we're working with in Azure in Fast Track, we're definitely pushing private clusters. That's what pretty much every customer is using for their production implementations. And the reason for that is they don't want to have any unnecessary public IP addresses, right? They want to have all of the services be privately accessible to just what they're doing inside of their virtual network, and really be able to lock those down as much as possible. So the way you do that in Azure If you're using a public service like Azure SQL Database or Azure KeyVault or our storage service, right? Azure Storage. You have the choice. Do you want to publicly connect to those from your applications, or do you want to privately connect to those from your applications? You definitely want to privately connect to whenever possible. So you want to be able to leverage private endpoints and private link as much as possible to lock down your Kubernetes cluster and everything it's connecting to, so that you're using private endpoints to connect to other Azure services. So the one that jumps right off the table first is Azure Container Registry, right? You're going to have to connect your AKS cluster to a registry, and Azure Container Registry is often used because it's so well integrated. You have the choice that Azure Container Registry could be publicly facing or it could be privately facing. You want to make it private facing only. So you want to disable public access to it and connect to it with a private endpoint. And so this just diagram here kind of shows you what we're talking about. Here we have a Bastion server running in a hub virtual network. That hub virtual network is peered to a a spoke virtual network that has the AKS cluster in it. You can kind of see what's going on here, right? We're using private endpoints to connect to, well, first of all, to connect to the API server because this is a private cluster. But second of all, to connect to other services like storage, like KeyVault, the container registries I just mentioned. That's the architecture you want to push. And note, going back to what I said earlier about that secure baseline reference architecture, which we have in the Azure Architecture Center, absolutely, if you start off with that, you're going to get this implementation. So we enforce these best practices as part of setting up those clusters. And so Sonalika, I had already talked about, I talked about north-south network traffic coming into the cluster and leaving the cluster and using NSGs and appropriately there. So I'll let you talk a little bit about east-west network traffic within the cluster with network policy.
Yeah. So we do have a concept of network policy for Azure Kubernetes Service. So the principle of least privilege should be applied to how traffic can flow between pods in an AKS cluster, right? When we talk about the traffic between pods in an AKS cluster, by default, when you create a cluster, right, by default, all pods can send and receive traffic without any limitations. Like everything is allowed between pods, which might not be acceptable in some of the scenarios. To improve security, principle of least privilege should be applied to how traffic can flow between pods within the cluster, and this can be achieved by using network policy, which is a Kubernetes specification to define access policies for the communication between pods. You can control both ingress and egress communication using this. Isolating applications within namespaces is a good idea, right? Like you are isolating your application within namespaces so that there is some isolation within the cluster itself, but it will not filter the traffic between those namespaces. So you can create network policy and assign it to namespace to secure the traffic communication. We do have two options for network policies. One is like Azure Network Policy Manager, which we refer as NPM, which is Azure's own solution. It translates the Kubernetes network policy model to set all allowed IP address pairs, which are then programmed as rules in the Linux kernel IP table module. So these rules are applied to all packets going through the bridge. And then we have second one we have is Calico, which is an open source and is widely used in the industry. If you see here my screen, how do we enable this network policy on the cluster, right? So when you create the AKS cluster, you have to define which network policy you want to choose. So you can say whether you want to have Azure or Calico in here. So if you see here, like if you want to choose Azure NPM, you can define Azure in here, or you can have a specify Calico as required. So if you want to, like, I'll just show you in here a sample uh, network policy YAML file. If you see here, like you can define your ingress here and from which ports, like which port and which ports are allowed, right? So you are in this policy template, you are saying YAML file, you are specifying that all the pod which has app label as app client uh, can communicate to pod which has label app server on port 80. So you are only allowing these pods to communicate to on port 82 pod which will have label as server app, right? So this is how you can control the traffic between the pods. Update the network policy to allow traffic from pods with the with these labels or within the namespaces. Anything you want, you can update these YAML files, and it will have a filter between your pods, which is not enabled by default. Over to you, Colin. Maybe you can talk about how we can expose our pods to outside, like externally, right? What is the best practices around it? Yeah.
Yeah. Good, great segue, Sonalika. And Azure policy, I love that. I love Azure policy. It's, network policy, Kubernetes network policy. It's fascinating to be able to like design your architecture, and you can use namespaces to isolate things, but namespaces don't provide any security context. However, you can apply those policies to a namespace, and then you really can lock stuff down. So you could say, this container cannot call that container. And there's just so much you can do with it. So it's really powerful stuff. Thanks, Nalika. So in terms of like exposing, speaking of exposing things, right? And one of the things that's really easy to do in Kubernetes is, hey, I'm going to deploy a pod. And I know, I'll just go ahead and set up a load balancer service. I'll create a load balancer service YAML, and I'll just go ahead and attach it, create a tag to attach it to the right pod, and I'm going to go ahead and expose that out to the internet, right? And you're going to get a nice. What that'll do is it'll tell Azure to put a public-facing load balancer in front of your service, and you're going to get a public IP address, and it just all works, right? Really bad idea. You don't want to do that. Do not use public-facing load balancers at all. So do not do that. And Sonalika a little bit ago talked about Azure policy. So Azure policy are these governance rules that we can apply to many situations. One of the more powerful ones that you should absolutely apply is this one, which is force your cluster or any cluster you're creating within your Azure subscription or management group to only allow the usage of internal load balancers. So what happens when you do this is you can no longer create an externally facing load balancer service and attach that to a pod. You'll instead have to use an ingress controller, which is a proper way of having that layer 7 ingress isolation in front of your service to be able to control what's coming in, what's coming out. You might want to have a web application firewall like we have with Azure Front Door or we have with Azure App Gateway. In fact, we actually have an ingress controller that's part of App Gateway that plugs right into AKS. But basically, it allows you to control this ingress because you really want to be careful as to what you're pushing out and how many public IPs you're allowing, right? You want to know exactly where they are and where they're not. So don't allow any sort of public-facing load balancer to be applied to a pod. You can turn that off in a policy and avoid these wherever you can in terms of public-facing IPs. So additionally, from an egress security perspective, that's ingress security, right? The load balancers that are allowing the data to come in. What about the egress side? So the egress side is really important to understand as well. So Sonalik and I have been talking about the importance of a private cluster, right? Which is enabling a private cluster when you create that cluster and setting up that private link and all that, so you don't have a public-facing IP address going to the control plane. However, if you, the thing is about this is by default, there has to be a load balancer, and there's the standard load balancer that's also part of the cluster. Basically, Azure needs to be able to egress, and so it needs to have a public IP address to allow egress. And so by default, even though you're creating a private cluster, you're not allowing private or public access to your control plane. You're going to actually create a public IP address for the cluster to enable egress if you don't know what you're doing. And so one of the big important points here is when you're creating your clusters, you need to set what's called an outbound type. That's this statement right here. And you need to leverage what's called user-defined routing to route your egress traffic over to an Azure firewall or another appliance that you're using in your network to have rules to inspect what IPs are you allowed to egress to, and this to control and have a firewall controlling that egress out of the cluster. So what this does when you set this up and when you have this statement inside of your cluster create, you're not going to get that public IP address that would be enabled automatically for egress because of the load balancer. So that'll go away, and now you'll be able to fully control egress out of the cluster properly through your firewall. This is an important point, and it's one that's easily missed and not understood. So we're just calling it out carefully here to really explain what's going on. You can use Azure Firewall here. You can use another NVA device if you want, but you definitely want to control the outbound traffic with a user-defined route. And by the way, what this means that the subnet that my cluster is going to, my agent nodes, my worker nodes are going to run in, is going to have a user-defined route on the subnet that pushes the traffic over to the firewall. So that's what this means. And if there is no outbound route set there on the subnet, when you try to create the cluster, it will fail. Give you a nice warning. Hey, you said you wanted to use an outbound type, but you just don't have a user-defined route set up. So that's definitely a best practice. And so let's talk a little bit about encryption, and I'll turn it back over to Sonalika.
Yeah, so like in any when it comes to infrastructure, right, like data is very important, and securing data becomes even more important, right? So AKS uses managed disk for its VMs and VM scale sets, and these disks are encrypted by, like, it has storage service encryption enabled for your data on the disk by default. So all your data which is stored on these disks are encrypted at rest. By default, this encryption uses Microsoft managed keys. You do have an option to use customer managed keys if required by your security standards. You can also enable host-based encryption to handle encryption before the data flows through your Azure storage, right? With host-based encryption, the data stored on the VM host of your AKS agent nodes, VMs, is encrypted at rest and flows encrypted to the storage service as well. So it is encrypted while sitting on the host, and it is encrypted when it is sent to your Azure storage. And of course, like, your disks are encrypted at rest as well. So if you enable this option, your data is encrypted from end to end, kind of. And this means the temporary disks are encrypted at rest with platform managed keys. and the cache of OS and data disk is encrypted at rest with either platform managed keys or customer managed keys, depending on the encryption type set on the disk, right? So if you want to enable encryption at host, it is not enabled by default. So first you will have to enable this feature on your subscription, because this does not come by default as enabled on your subscription. So make sure you enable this feature. It takes some time before it gets registered, and once it is registered, then you can enable, like when you create the cluster, right, you can add this option within it to enable encryption at the host level as well. Then that is like one part of your data, right? Second part is like secrets. How you are storing secrets, and where it is stored, and how you will be accessing it. Is it like secured or not? When it comes to like secrets and managing passwords and everything, it becomes very critical when you are accessing your application. So it is like to have it in the most secured way, it's like best to externalize application secrets to KeyVault and connect to Kubernetes secrets pods or environment variables. Azure KeyVault provider for secret store CSI driver allows you to get secret content stored in Azure KeyVault instance and use the secrets store CSI driver interface to mount them into Kubernetes pods. It supports auto rotation of mounted contents as well, and syncs Kubernetes secrets by polling for the changes periodically based on the rotation poll interval you have defined. So you can enable auto rotation if you are doing any changes. Like when you are a developer, it becomes a big challenge, right? Like if I am rotating my keys or updating my secrets or passwords in my key vault, how will Kubernetes those environment variables or secrets within Kubernetes will get updated? So you do have an option to sync that or get it auto rotated based on the changes you are doing. In the keyword. By default, it is 2 minutes, but you can set the polling interval as well. So it would be best to keep it in Azure Key Vault and have a use CSI driver to get secrets or pass or any sensitive data from your for your applications, right? So that's what we have for secrets here. And now we'll move to identity. So Colin, can you tell us more about identities and which one we should use moving forward, and what are the best practices around it?
Yeah. Great. Thanks, Sanalika. So identity is an important, I mentioned we're not going to talk about application identity. I guess I kind of lied because we're going to talk about it a little bit. And so your applications themselves are running in pods, right? And they're going to have some sort of identity. If you've integrated your cluster with Azure Active Directory, which you really should, then we've talked sort of about across the theme here of not having passwords wherever possible, not having to manage credentials, and that's great. You can actually do that because there's going to be a managed identity that's assigned to the cluster that your application could potentially use to pick up an AAD identity, an OAuth token that you could use to potentially connect to maybe a SQL database or a key vault or storage account or whatever the Azure service is using Azure Active Directory, and having your identity flow to that service. So everything can be locked down with RBAC and whatnot. So the way to do that traditionally with AKS has been to use something called pod identity, which we've had available in preview for a couple of years now. And this allows, I'm not going to talk too much about this, but this allows you to set up your pods so they can actually take on a managed identity. And each pod could have its own managed identity token that it can then use to securely connect to its resources. So every single application that you're deploying to your cluster can be individually secured as to what it can and can't access, and really have least privilege across sort of the whole deployment. That's what you want. Now, the thing with pod identity, though, is it's very proprietary to Azure and to AKS. It didn't, you couldn't sort of use it and then maybe took your deployment and said, hey, I want to run this on another Kubernetes a cluster somewhere else outside of AKS. Wouldn't work. So what we've done is we've sort of deprecated this technology. I recommend not using it, as this is going away. Eventually, it's still there. We're still supporting it, but we have a better solution, which is much more open to other clouds, because this solution is called Workload Identity. And basically, what this essentially does is it leverages a feature of Azure Active Directory called Workload Identity Federation. And this allows you to access Azure Active Directory resources without needing to manage secrets. It integrates in with Kubernetes. So it allows you to leverage sort of the native Kubernetes features to federate to external identity providers, which is really, really, really cool. So what you're doing with this will work in other clouds as well as on-prem. In this model, essentially, the Kubernetes cluster essentially becomes a token issuer. It issues tokens, and it does so by sort of signing a Kubernetes service account. So it uses service accounts in Kubernetes. Will sign those, and then it will then send that over to Azure Active Directory and exchange it for an AAD token. Essentially, you'll get back a token from AAD, and then you'll basically be able to eventually have a managed identity. Now, right now, it doesn't work with managed identities. So managed identity is another Azure feature, which is essentially a wrapper around an Azure service principal. Today, this technology, Workload Identity, works with service principals in AAD, does not work with managed identities yet. That is coming, and will be, we think, public preview probably into this month-ish, and we're hoping for general availability, end of year, perhaps going into the next calendar year a little bit. But what you'll then be able to do is map your Kubernetes service accounts to managed identities for each individual pod. Each pod will take on an identity and can connect to other Azure resources, essentially without sort of having to have any secrets. You don't have to go to KeyVault to say, hey, give me that connection string with the passwords so I can use it to connect to the database, right? All that will go away, and you'll be able to flow OAuth tokens all the way to other services. So definitely look to use this in your applications later on this month, next month, as this becomes available with managed identity support. And by the way, the managed identity support is absolutely needed for CSI providers like the Azure KeyVault provider for secret store CSI driver. All right. So let's stop here on identity and let's go back over to Sonalica and talk about some important aspects around patching and upgrading, which is really, really critical to security. So switching over to you, Sonalica. Oh, it looks like Sonalica is definitely having an issue with probably her network, and that's really unfortunate. So we'll get to her in just a minute. This happened to me yesterday. It's actually, we had a major power outage in my neighborhood, and my machine just crashed. And luckily, that didn't happen now. But it seems like Sonalica is going through something similar to that, and we apologize. But what I'll do is I'll skip that, and we'll come back to her right when she connects back in. And I want to mention quickly, I want to talk a little bit more about scanning images with Microsoft Defender, because this is a really important thing to understand. So Microsoft Defender, Sonalica talked about it a bit, enables you to scan registries. So any image that is pushed to the registry will be scanned immediately, right? So This gets applied to Azure Container Registry. It's integrated with Qualys and that scanner, and it'll scan and pull out known vulnerabilities. Note here that there's actually 4 different triggers for image scans. So scrolling down here, you can actually see those various different triggers that we actually have. I'll pull that up here in a second. Oh, it's up here. But basically, so we'll definitely trigger when you when you push an image in, and there's 3 other configurable triggers as well. And what you'll get out of this is the ability to kind of see, hey, this is the number of images that were scanned, and here's sort of the vulnerabilities that were found. And it's a pretty powerful technology that's just now baked in and enabled for you by simply just turning on Defender Defender for containers. In addition, Sonalika mentioned this, and I wanted to kind of go back to it, double click on it here a second, which is the ability to scan images when they're getting built by your CI/CD workflows. This is a feature that we have now available in preview, and basically what this enables is you, when using GitHub and using GitHub workflows for your CI/CD deployments, you can now automatically sort of scan your images that are getting built from your code. As your code gets pulled out of GitHub and you actually compile and build that container image, you'll get an immediate scan. And this actually leverages Aqua Trivi to do the scanning. So you're actually getting 2 different scanning technologies here. That's an advantage, right? So you have different sets of tech that are being applied both at the point of building the image, and then once it gets pushed to the Azure Container Registry, it'll get a Qualys scan through through Defender. So very, very cool. So definitely look at this. If you're using GitHub, which you really should be thinking strongly about if you haven't yet, and you're using GitHub Actions for your workflows, you can absolutely set this up and turn this on and scan now at multiple levels. Additionally, we talked about this a bit, but I want to double click on it as well. Locking down Azure Container Registry with RBAC. This is actually another Azure policy that we have available for you. So this is a policy that you can deploy through your governance across your whole cluster, across your whole subscription or even management group, that says we probably only want to apply this at a cluster level, actually, which says, hey, this cluster must only pull images or can only pull images from this registry. So having something like this policy in play protects you from, let's say, a bad actor did get deployed to your cluster. So something got deployed there that shouldn't be, and now what it can't do is go out to the internet, pull down and and start up deploy something and pull down some image from, could be from some open source image library out there on the web, some registry, could be anywhere, right? It can't go grab a container image, pull it down and start up a container, because we're only allowed to start containers from images that are coming from a protected, secured cluster that we've okayed. So this is absolutely a policy that you'll want to enable on your cluster and leverage to ensure for certain that images aren't getting deployed except for where you wanted them to be deployed from. So since Sonalika is not back yet, I'll just jump in and talk about the last couple of topics that we wanted to quick mention here, which really are important. And that is, so basically upgrading and patching, right? This is operational stuff, but operational stuff really, really ties into security. I think we all know that, right? And knowing and doing it right is part of a security best practice. So we're going to have to mention it here in this Learn Live, and we should. So just so you understand what happens with Kubernetes and AKS, we basically patch the Linux VMs that are running your applications nightly. So we're pulling down patches daily and applying them nightly, and that's just constantly happening. We're going to do it for you. Note that some patches require a VM to be restarted before the patch can be actually enabled, right? So some patches require an OS reboot. In the past, we had something called Cured to do this. It's still available. It's a daemon set. This was a traditional way to restart nodes when you had to for nightly restarts, right? To apply those patches that may require an OS restart. But there's actually a much better approach. And so rather than having this daemon set that's just kind of randomly restarting nodes each night, and it'll do so in a cord and drain fashion, you can get away from that. And we actually have something called node image upgrades, which is a better way to do this. And what we basically do here is we weekly release node images with the latest kind of OS runtime updates on it. So we release a new image of the OS weekly with all of the updates already applied to the release, and we allow you then to to use those images and apply those to your cluster. And what we'll do by simply following the guidance here is we'll then at a certain point in the weekend or whatever you want this to happen, we will then apply those new node images in a cord and drain fashion across your cluster, restarting each node as necessary and reapplying this patch tested image that's been certified. So it's a much smarter, better way to go rather than continually patching something that you installed 2 years ago. You now actually are getting a new tested OS once a week with all the updates on it that you need for much better management. So basically the main difference here, I'm showing you this AKS create upgrade call statement, and the main difference between AKS create update when used with node image upgrade only is that when we do this way, so you can see what I'm pointing out here. When we do this that way, only the node images will be upgraded. If it's omitted, both the node images and the Kubernetes control plane will be upgraded. So by having this, by having that feature, you're only gonna do node image upgrades on the worker nodes, on the agent nodes. But if you omit that, we'll do it on both the Kubernetes control plane, which we manage for you, as well as those agent nodes. You can also leverage maintenance windows here. So we have this totally set up. Planned maintenance windows allow you to schedule weekly maintenance that will upgrade the control plane as well as the kube system pods on the BMSSs. Once you schedule your maintenance window, everything that you want in that from the perspective of these upgrades will happen in that maintenance window. So that gives you all the control of when this takes place. Very, very handy. And just note from a security hardening perspective, if you have questions around that, AKS provides a security optimized host OS by default. So we've already done all the hardening that is needed for the OS. You don't have to kind of go in there, SSH in, and do additional hardening. We're giving you a hardened OS. Additionally, I want to mention quickly upgrading Kubernetes, and then we'll kind of close up. So we're getting close to being done. But basically, another thing that you need to do is you need to regularly update to the latest version of Kubernetes. You have to stay, we require for support reasons for you to stay within N-2 releases of our officially supported Kubernetes versions. So, you basically need to be within 2 releases of the latest, because we need you to continue to upgrade that cluster so we can support it. You can then you can choose to apply Kubernetes and have us automatically upgrade your cluster for you, which is really probably the recommended advantage, the recommended way we would suggest. Or you can manually sort of decide when you want to apply these changes. And like everything else, always do stuff in a test environment first, a staging environment, then production, right? And the same goes for this, right? When you're doing these kinds of changes, when you're upgrading Kubernetes, do it to your lower environments first. So it's important to do that upgrade. Really easy to do. Just kind of follow the guidance here, and you can run these commands. You can script this, and then you can pretty much apply these upgrades. All right, and automatically updating your cluster is very simple. So it looks like Sonalica definitely had a network issue and was not able to rejoin, but we have reached the end of what we wanted to talk about. So everything we've talked about here is wrapped up in that collection that you're going to get, that you can access. So every link that we're showing you is there. You can pull that up and kind of go through these best practices and see kind of the full set of what we're recommending you look at. And then, of course, you can replay this Learn Live on demand as well to kind of back up and kind of get links and understand a little bit more and map that to the collection if you'd like. So we've covered today the cluster level concerns. We jumped into networking concerns from an ingress, from an egress, from east-west, from a north-south perspective. We talked about developer configuration, encrypting secrets and managing secrets, using Azure policy, of course, and then, of course, the workload identity that I mentioned just a little bit ago. And then, of course, image management with like scanning and containers for Defender for containers, and leveraging those features to flush out vulnerabilities. So basically, you can get access. It looks like Sonalica is back, and hey, Sonalica, I actually went ahead and covered the patching and the upgrades and such, and so all good. And we know you had a network issue. I've been there, had that happen to me yesterday, actually. Luckily, I wasn't doing this, but I want to say thanks to you for trying to stick through it as much as you could, the issue that you're having, and I think we got everything covered. So we want to say thank you. Basically, leverage this link to get those that collection of links that I mentioned, and to be able to learn, practice. We actually have some good learning links there for Learn modules that we recommend you go through to actually learn about some of these security practices. So absolutely do that. And lastly, I want to point out that the next one of these sessions, do not miss it. We will be doing another Learn Live upcoming on September 27th. Notice this time here. This is Australian Eastern time. This is not Eastern US time. So Australian Eastern time, 2 p.m., September 27th, and this is on Azure ML Enterprise deployments. Definitely come to this, and thank you very much for your time. Sonalica, thank you, and we really appreciate it, and we hope that you're able to get a lot out of this.
Thank you, everyone.